Good afternoon, GPA families. It's Mr. Sargent here with your Day 40 recap video for ELA and for science. Now, in ELA today, we're going to be talking about some more fables and focusing on the central message for those fables. In science today, we're going to be doing a quick review over facts of the states of matter, the solid, liquid, and gas. And we're going to be introducing a new topic called density, in which we do a quick little experiment. So stay tuned. In ELA today, we started by talking about fables and what fables were. Fables are stories that usually use animals to help teach a lesson and tell us a story. The big thing about a fable is that it will have a moral, or the lesson that we learn. Now, what we're going to be doing is reading and listening to the story, The Fox and the Crow. Now, as we watch this, I want you to see if you can identify the beginning, middle, and end, as well as how these events are connected in order to teach us the central message of the story. So, let's go ahead and watch this fable.
Fox was out walking when he saw a pear on a high branch, way up there. Fox licked his chops and set his sights on it. But before he could get there, a crow was upon it. Crow eyed the pear, and before Fox could speak, she plucked the pear with her shiny beak. Now foxes are clever and don't give up quickly. In half a moment, he came up with a trick. He walked up to the tree with a smile slick and sly, and said, "Noble bird, on your perch way up high, the sheen of your feathers attracted my eye when your beautiful form fluttered down from the sky." Crow liked the sound of what she was hearing, and found this fox fellow to be quite endearing. "And not only lovely," the fox said, "but wise. In a cleverness contest, you take the first prize." Crow thought, "I am pretty and rather well read," and the words the fox said went straight to her head. "Could I beg you to do just one thing for me? Sing me a tune, a sweet melody. If your voice matched your looks and your fine way with words, surely you'd be the queen of all birds." Fox, satisfied that his plan had succeeded, said, "Crow, it's not pears, but this lesson you needed."
So if you did your own BME chart, you notice that the first event is fairly simple. The fox sees the pear. That's it. It's a great event. It sets the stage for the entire story. Now, our middle is where the problem is going to be. And this is where we had some debate. Could it be when the fox was trying to give compliments to the crow? Well, it could be. But really, what it was that the fox asked the crow to sing. And that leads to our ending. The ending is the crow dropping the pear. Now, the lesson that I think it is be careful not to get too self-centered. And self-centered means that you think you are the best at everything and all these people are giving you compliments, you can do no wrong. Well, that was all part of the fox's plan, wasn't it? The fox had a plan, had a goal in mind, and the fox wanted the pear. And it was using the crow's own self-centeredness, thinking that it was the best ever at everything, that the fox was actually able to get the pear. Now, what I really loved is the last line in the fable. And I'm going to paraphrase here. When the fox looked back, eating the pear, he's like, you know, this wasn't about a pear. This was about a lesson that you needed to learn. And do you think that the crow learned her lesson? I definitely think so. So we then transitioned over to the story, The Blue Coyote, which is a Native American fable. A couple things that I want you to look for after we're done reading is I want you to find the BME, I want you to find that beginning, middle, and end, but I also want you to see if you can figure out what is the lesson from the story. The Blue Coyote. Long ago there lived a hungry coyote. One day he found a juicy bone. He grabbed it and ran away. When he jumped over a fence, he landed in a big tub filled with blue ink. Now his fur was bright blue. The coyote went to the forest. The animals had never seen such a strange blue creature. They were scared and ran away. The sneaky coyote thought of a plan to make the animals give him all the food he wanted. He told the animals he was their new king. They believed him. They also brought him all the food he wanted. One night, he heard coyotes howling at the moon. He could not stop himself. He started to howl too. Ow! When the other animals heard him, they knew he was just another coyote. They were angry at being tricked. They chased the blue coyote right out of the woods. So what do you think? Now, this isn't about me telling you what the lesson is or all these things. This is about what you think. After hearing and reading the story with me, what do you think the author was trying to teach? Well, it could be a number of different things, and I would love to hear your answers. So I want you really to think about, what is the lesson? Using the events from the story, what lesson was the author trying to teach us? I'm going to leave it up to you. Now on to science. Now, as you can see, yesterday I had some fun with science. I was able to show the effects of dropping a gas, a liquid, and a solid on my head. As you can see behind me, and you're probably just focusing on that right now. But what we need to do today in preparation for tomorrow's experiment is we need to learn a little bit more about solids, liquids, and gases. Now, we've already started the chart in class, and if you haven't seen the chart yet, I'm going to put it up in a second. What we need to do is both identify what the molecules look like and some important facts about solids, liquids, and gases, as well as some examples. So let's go ahead and get started. And after this, we have a quick experiment to show you just what density is. First, let's talk about solids. Now, as you can see, the first thing you should put in your chart is that the molecules are really close together. There's not enough space to get anything by these molecules. This is why we're not able to walk through a solid. Some other facts about solids are that it has its own shape, meaning that you can't really, it has its own design, it has its own shape. And if you put it in a container, it doesn't take the shape of the container. It's still going to remain what it looks like. Now, take it, for instance, a Lego. If you have a solid Lego, well, if you put it in a container, it's not going to look like a container. It's going to look like the Lego. So, fact number one, they keep their shape. Now, the only way to change how a solid looks is to do something to it, whether break it or melt it or cut it. If you think about a piece of paper as an example, a piece of paper is solid, but the minute that I cut it, it changes its shape. And that's the thing about solids. They can change their shape only when you add either heat energy or you do something to change how it looks. Now, liquid, on the other hand, does not have its own shape. All right, the most important fact about a liquid, other than its molecules are far enough apart where we can pass through them, but we still end up getting wet. The most important fact is that, well, they don't have their own shape. They take the shape of whatever container they're in. Think about a soda bottle, think about a cup or a glass. Whatever the liquid is put in, it's gonna take that shape. It really has no shape of its own, which is pretty interesting. And another cool fact about liquids, they can pour, drip, flow, and splash. The other states of matter can't do that. Now, if we think of some examples, we have water, milk, oil, gasoline, juices. These are all liquids, all right? So anything that can be put into a container, and it takes the shape of the container, that's a liquid. And gases, much like liquid, take the shape of its container. Think about a balloon. You add gas to the balloon, it's going to take the shape of the balloon, isn't it? But the cool thing is, if you think about the molecules of gas, they are so spread out that we can walk through them, we can breathe them, we don't even notice they're there, all right? Some examples would be oxygen, carbon dioxide, helium, steam, exhaust from a car. These are all examples of a gas. So the question that I have is this. Now, are all gases, liquids, and solids the same? Well, my answer is going to be no, but how do I know? That's what we're going to focus on next. For tomorrow's experiment, once again, you're going to need a few things. You're going to need cooking oil, water, a container, food coloring if you want to, a flashlight if you want to. But what we're going to test is my question from earlier. Are all liquids the same? Do they have the same molecular break apart? Are their molecules the same distance apart? And this is when we learn a little bit about density. So instead of about liquids today, we're going to focus on gases. Can gases be heavier or lighter or denser or less dense than other gases? So let's first talk about what the word density means. Now, if we're talking about density, we're talking about how compacted the molecules are. Now, this necessarily doesn't have anything to do with weight, but it does have something to do with the state of matter. Now, when you think about a gas, their molecules are all far apart, whereas a solid, they're all really close together. So a solid is more dense than a gas. But the question that I have is, can different gases have different densities? Let's go ahead and test this. So the ingredients that you're going to need for this assignment, if you see right behind me, you're going to see I have a container, I have some baking soda, I have a lit candle, and I have some vinegar. Now, what we're going to do is I'm going to put in the baking soda first, and then what I'm going to do is I'm going to put the vinegar in. Let's take a look at the reaction that takes place. So what's happening here, if you can see it, is the vinegar is mixing with the baking soda, creating gas. You can see the reaction, those little bubbles everywhere. Now, this gas is not oxygen. What's being created here is actually carbon dioxide. Now, the thing about carbon dioxide is it is a more dense gas, which means, will it float or will it sink? Well, it's going to sink. The more dense something is, the more it's going to sink. So now to prove that there's carbon dioxide in here and it's denser than air, we take a look at the lit candle. Now, what does fire need in order to survive? Well, it needs oxygen. So in a sense, the carbon dioxide should put the candle out. So what I'm going to do is I'm going to pour the carbon dioxide out of the container. Now, I'm not going to move any of the liquid. I'm just going to dump the carbon dioxide out. And let's take a look at what happens. So just to review, if you notice from our experiment, the gas that came out of our mixture of vinegar and baking soda was a lot denser than oxygen. And here's how we know. Well, it blew the candle out, all right? That gas actually sank right to the bottom. If something is denser, it's gonna sink. If something is less dense, it's going to float. Now, tomorrow we're gonna be doing an experiment with either dense or less dense liquids, and I can't wait. We're gonna be doing that in class. So tonight, do not forget to check out your States of Matter assignment on Google Classroom. Keep reading, keep doing your spelling work, and ladies and gentlemen, most of all, I hope you have a wonderful and incredible evening.